Okay, welcome. We're about to do the key questions on page 110, which is at the end of 3.3, and this is on relative motion. Okay, so skip ahead at any time if you think you've done these questions, you don't need any help. I'm going to be doing one video, probably covering about 2 or so questions, and then there are 7 questions all up that you have to do. So question 1. Question 1 says the velocity of a car relative to the ground is going to be given as the vector CG, VCG. So that's car relative to ground. And the velocity of a train relative to the ground is given as, let's see, what do they say? It's TG. Okay. Now, the relative to the ground is just simply what we're going to call the velocity of the car. Okay, what we would normally reference as, it's just the normal way that would say this is the velocity of the car, this is the velocity of the train. Okay. What would be the velocity of the car relative to the train? Okay. Now, the velocity of the car relative to the train, so car, rel, train, is equal to the velocity of the car minus the velocity of the train. Okay, so let's have a look at, that's the actual answer. Write out the equation to find the velocity of the car relative to the train. Okay, so that's the first one done. Question 2. A small boat pushes off from the edge of a river at 2.5 meters per second north. So this is the small boat pushing north. So let's just give ourselves a river. Okay, here's our little boat. Okay, there we go. And it's going north at 2.5 meters per second. The current is flowing downstream from the west. So this is the west and there is the east. So the current of the river is going downstream at 0.8 meters per second. What's the resultant velocity of the boat? Now in this case, I'll move that up a bit. This case, the overall velocity is, what is the velocity, the total velocity of our boat? Well, our boat's velocity is going to be this plus this. So the total velocity of the boat, this is the velocity of the boat relative to an observer standing on the shore. In other words, is the boat as viewed by the ground, that's the velocity BG, in this case would be equal to the velocity of the boat, plus the velocity of the water. Okay, so let's do that. So if we add them, the velocity of the boat is 2.5 meters north. The velocity of the water is 0.8 west. So the actual boat would start to move in that direction there, okay, and at that angle. So the overall velocity of the boat will be given by Pythagoras's. So the velocity of the boat as observed by the stationary observer would equal the square root of 0.8 squared plus 2.5 squared, and that would be, just calculating that, 0.8 squared plus 2.5 squared, square root of the answer. The boat will be moving at 2.6 meters per second squared relative to the ground, because it's not just moving with its own velocity, it's also moving with the velocity of the water, and its overall velocity would be 2.6, and the angle that it would be moving, it would be tilted towards the downstream by this angle. So theta would equal tan the minus 1 of 0.8 on 2.5, because that's tan opposite over hypotenuse. Remember, this is the 22.5. Let's get rid of that. And so the angle would be, shift tan of 0.8 over 2.5, and that's 17.7 degrees. Okay. If you don't need question 3 or 4, you can skip the next one.